In this video, I'm going to be doing some more examples of using the chain rule. So in the last video, we introduced the idea of a composite function. And so in y equals the quantity 3x minus 7 cubed, 3x minus 7 would be my inside function, which we call u. And then the outside function would be this quantity x cubed. So what we want to do is, let me rewrite this, y is equal to 3x minus 7 cubed. We're basically going to use the power rule here. We're going to bring down the exponent 3, and then we are going to write the inside function, and then we are going to reduce the power by 1. That is the power rule. And then the chain rule part is when we tack on to the end the derivative of the inside function, which in this case is just 3. Cleaning this up, we would get 3 times 3 is 9 times 3x plus 7 squared. And we can just leave it like that. We don't necessarily need to square the 3x plus 7 and multiply all that out. We can just leave it like this. All right, so in the next example, it's similar. The inside function is once again what is inside the parentheses. That is my u. And so we have use of the power rule. So we're going to bring the 5 down in front times the inside function, reduce the power by 1, and then the chain rule is we tack on to the end the derivative of the inside functions, which would be 15x squared minus 2. Now we have a radical. So remember, in a radical, the square root in this case, the inside function is what's underneath the radical sign. So I will have y is equal to 2x minus 5, and I'm going to write that to the 1/2 power. Now applying the power rule, y prime is equal to 1/2, bringing the 1/2 down in front, times 2x minus 5, subtracting 1 from the power, so we have negative 1/2. And now the chain rule part. I always emphasize that because this is the part that people forget. We need to tack on as a chain, link in a chain, the derivative of the inside function 2x minus 5, which is just 2. And so we can clean this up. 1/2 times the 2, 1/2 times 2 is simply 1. And then we have 2x minus 5 to the negative 1/2 power. And so we would prefer to write that without a negative exponent and write it as a radical. So this would be 1 over 2x minus 5 square root. And another exponential. Remember, with an exponential, the exponent is the inside function. And remember how we find the derivative of an exponential function. The derivative of y equals e to the x is simply e to the x. So the derivative of this is going to be e to the 4x cubed minus 2x plus 1. It is its own derivative, but we have to use the chain rule. We now tack on at the end the derivative of the inside function. You're never done until you tack on the derivative of the inside function, which will be 12x squared minus 2. And that's good enough for that. We could write this out in front, but it doesn't really matter. A logarithm. Okay, so remember that the derivative of the log of x is simply 1 over x. So we're going to do the same thing here. The derivative of this is 1 over, my inside function now will be what's inside the parentheses, but we're going to do it as 1 over the 3x squared plus 2. But now the chain rule is we tack on the derivative of the inside function, which will be 6x. And we can clean this up a little bit by putting the 6x over 3x squared plus 2. The exponential again. The exponent, as always, with an exponential is my inside function. So we have y prime is e to the x squared plus 3. And now we tack on the derivative of the inside function 2x. That is the derivative. Well, it is possible to use the chain rule along with the product and the quotient rule that we've learned. And so the next two examples will be those types of problems. So first of all, notice that we have a product of two different functions. We have function here, and we have this function here. So I'm going to call f of x, x squared, and g of x is 3x minus 5 to the fifth. So I'm using the product rule here because I have the product of two different functions. Well, the derivative of f of x is 2x. The derivative of g of x, well, we have a composite function. This is my inside function. So just like we've been doing, I'm going to use the power rule here, bring down the 5 times the inside function to the n minus 1 power times the derivative of the inside function. And then that cleans up to be 15 times 3x minus 5 to the fourth. Now we put all of this together inside the the product rule. So y prime, remember that y prime is f prime g plus fg prime. That is the product rule. So f prime is 2x times g is 3x minus 5 to the fifth plus f, which is x squared, times g prime, which is 15, I'm going to put that in parentheses, times 3x minus 5 to the fourth. And so that is the derivative, unsimplified, using both the chain rule and the product rule. But what we want to now do is simplify this by looking for common factors and factoring them out. So let's look at the coefficients or the numbers. I have a 2 here, and I have a 15 here. There are no common factors for those, so leave them alone. I have some powers of x's. I have x to the first, and I have x squared. Least common factor is an x, so I can pull out 1 power of x. And then I have 3x minus 5 to the fifth power, 3x minus 5 to the fourth power. So I can pull out a 3x minus 5 to the lowest power. Remember, when we're factoring common factors, we always factor out the lowest power. So that would be the fourth. So that's what I'm taking out. Then what is left behind that goes in the parentheses or brackets is what's left over. So from this term, I took out the x, I did not take out the 2, and I took out 4 of these 5. So I have 1 power of 3x minus 5 left over. Plus, in this term, I did not remove the 15. I removed one of these 2 powers of x squared, so I have 1 left over, and I took all of these out. And so that is factored, but let's clean it up just a little bit more by simplifying what's in the parentheses. So this would become 6x, this is minus 10, plus 15x, and then that can become 6x plus 15x would be 21x minus 10. And since this is all raised to the first power and x is raised to the first power, we could then write this as multiplying the x times this. We get 21x squared minus 10x. And that is in parentheses. And we have the 3x minus 5 to the 4th power. And that would be the best way to write the final answer. This problem, we have a quotient. And we have a composite function in the denominator. So with the quotient rule, we know that we find the derivative by doing f prime g minus fg prime, all divided by g squared. So the numerator is my f, and the derivative of that is 6x plus 2. The denominator is my g of x, so that would be x cubed plus 1, quantity squared. And then the derivative of that, using the chain rule, is 2 times x cubed plus 1 to the 1st power times 3x squared. And so I'm going to simplify that by multiplying the 2 times 3x squared to get 6x squared times the x cubed plus 1. And we could even multiply these two together because this is raised to the 1st power. And so we would have 6x to the 5th plus 6x squared. That's my g prime. Okay. Now let's put it all together in the quotient rule. So y prime, now doing a different color, is going to be f prime, which is 6x plus 2, times g, which is x cubed plus 1 squared, minus f, which is 3x squared plus 2x, times g prime, which was 6x to the 5th plus 6x squared, all over g squared. So we're taking g, which is this quantity squared, and we're squaring it. So what we end up with is x cubed plus 1 to the 4th power. And so what we could do is we can simplify the numerator a little bit. We can't multiply these together because this is raised to the 2nd power. We could use the FOIL method to multiply those two together, but that's just going to give me a long string. So the important part here is just to find the derivative and use the chain rule and the quotient rule together. So I will leave the ultimate simplifying up to you.